Good day, everyone. So now um, we have already discussed about basic programming, that is addition, subtraction, multiplication, and division by using the registers, and one other variant is like from taking it from the memory, the input from the memory, and after finding out the result, giving out the result into the memory. So that we have discussed already. So now in this video we'll be discussing about quite other variants of basic programming, like sum of n numbers, factorial of n numbers, then largest of n numbers, and ascending order sorting. So these are the programs that we are going to discuss in this video. In addition to that, we'll try to do port programming also. Okay, so now getting into the program, first we'll go for this sum of n numbers. So I have already typed the program, so let us discuss what is the meaning of each and every instruction. So as far as this video is concerned, so you need to go through the first video, then this video will be easy for understanding. So the usage of memory and other things we have discussed in detail in the earlier video, so I am making it short, so I'm not getting into the details of those things, so that the time factor is reduced. So here in this case, the first line, you all know what does it mean, the area, then label, any label you can give, comma, code. So whatever the things that I'm going to write after this line is going to be a code, and comma, space, read only, and the program has to be saved in the read only memory. So the first instruction is for initializing the memory address. So mov r0 comma hash 0x40000000. So this is the starting memory address, and when I'm using this instruction, only this value gets into R0, and I will be using the R0 content as a memory address in the next instruction. So coming to the next instruction, it is LDR R1 comma within brackets R0. So the content of 400000 is fetched into R1 register. So in this case, the first value that will be fetched into R1 will be the size of the array. So size of the array in the sense it's a sum of n numbers. So in case if I'm giving 5 different numbers, I'll have to specify 5 first, and then the different 5 numbers I'll have to specify. In that way this program has been written. So add r0 comma hash 0x04, this is to jump to the next memory address. Next memory address in the sense 32 bits will be consumed by the first block of memory, so I'll have to jump to the next block, so that will be available in 40000004. So to go to that, I'm adding 4 towards R0, then LDR R2 comma within brackets R0. So now I'm getting the first value into R2. So R1 will have the size of the array, R2 will have the first value that to be summed up to the next value. So this is R2 is there. So when I fetched one data, I'll be writing subtract R1 comma hash 0x01. So R1 is having the count, so the count is reduced by 1, so mentioning that I have taken one value. Then I'm making add r0 comma hash 0x04, so I'm jumping to the next memory address. So the R2 will have the first value and R3 will have the second value, while R1 does have the size, so that we'll have to keep it in mind. So add r0 comma hash 0x04 goes to 40000008, so that the next second value that has to be added to the first value is fetched. So that is fetched using this LDR R3 comma R0 instruction. So R2 and R3 does have the first and second values, so that is fetched and that is being added in this instruction. Add, yes, you all know what does it mean. So add is in the sense like after doing the addition operation, the concerned flag has to be set or reset, so it has to be affected after the execution of this instruction. So for that reason we are putting this yes. So in case if we get a carry, that will be represented in in this R4 register, add R4 comma hash 0x01. So in case if you don't get a carry, so you'll be jumping, so that this instruction will not get executed. So next is I mean, since I have taken the second value in R3, for that I am subtracting over here the content of R1. So R1 is having the size of the array. So I already at this instant it has become in case if it is 5, in this instant it becomes 4, and in this instance it will become 3, because like here one time I have fetched one data, and in R3 I have fetched the second data, so 2 times subtraction has been done. And then using this subs I am making the flag registers get affected. So in case if R1 has gone to 0, then I'll come out of this loop, otherwise I'll get into the loop, because like it is a sum of n numbers, any any number of numbers I can give, so it's like n. So for that case I'm putting it inside the loop, so using this bne instruction. So if 0 flag is not set, then I'll jump to add r0 comma hash 0x04, so it becomes 400000c, so that the third data is fetched into R3. So R3 will have the third data, while R2 will be having the summed up value. So R2 will behave like a at the last it will have the whatever the summed up value of all the arrays as such. So after this when two values has been fetched, and a third value is fetched into R3, so that is summed up, and again it checks for carry. In case if carry is there, then R4 will be representing the carry, and then again subtraction happens. So again it will check whether R1 has gone to 0. If it hasn't gone to 0, then it will jump to add R0. So fourth value will be fetched, and that also will be added. So this goes on and until your R1 goes to 0. When R1 goes to 0, this comes out of the loop, and add R0 comma hash 0x04 happens. So after the last value that has been entered, so to word switch to the memory, 4 value you are going for adding, so that it jumps to the next memory address for putting the result into. So after jumping over there, str r2 comma r0, so towards that memory address I am moving the sum. So R2 is having the total sum that is moved into the memory address. Then again next memory address I am jumping to move the carry. So R4 will have the carry, that I will be moving it into the consecutive memory address. That is the end of the program. So now let us check how the program runs. Translate, build. So it is showing a warning. We can put end statement at the last. Warning you can ignore, but anyway, 0 error, 0 warning. So we can get into the start stop debug session. So assume that we are going to give 5 numbers. 5 numbers I'll have to give. I'll give minimum numbers 6, 7, 2, 3, 1. So 1, 2, 3, 4, 5 are the data that I am feeding in. 5 is the size. So you can see 1, 2, 3, 4 and 5. 5 data I have given. So we need to check the program's execution. So R0 is initialized with the memory address. So the first data has been fetched. That is the 5. It's not a data, it is the size of the array that has been fetched. Then I'm going to the next memory address, and this is the first data as far as this values are concerned. 6 is your first data that has been fetched, and your R1 is subtracted by 1 because we have fetched the first data. Then your memory address is pointing the next memory address, so it has jumped to 40008 that you can see over here. Then the second data has been fetched into the R3 register, then addition happens. So D is the result of adding the first and second data. Then again, I mean, your R1 is subtracted, so R1 goes to 3, you can see. Then again R0 is incremented, so it points to 40000C. so the next value is fetched into R3 register, that is 2, and 2 is added with D, so you get F. And then again, since the third value has been fetched, so you go for subtracting the R1, so R1 becomes 2. Then again it jumps, again memory pointer goes to the next memory location, and the fourth value is being fetched, 3, that is fetched to R3, then it is added to R2 12. Then subtraction happens, so subtraction of the size R1, so that becomes 1. Again it goes, and the last value 1 is fetched, then it is being added, then again R1 is subtracted, so R1 becomes 0 now, so it will come out of the loop. So it does come out of the loop, and memory address is incremented, so R2 values stored in the consecutive memory 13 that you can see over here. Then the carry is stored in the next consecutive memory, so that is 000. We didn't get a carry, so in that case we are getting 000, that you can see from the color, the change in color. So this is the result, while this is the carry. So this is the explanation for sum of n numbers. You can try with different values. You can give maybe 6 values or 7 values or maybe lesser, and the value of the components that you are feeding in, you can raise its value, and you can check. You can check how much, whether it is getting a carry or not. Those things you can check for yourself. So this is for sum of n numbers. So the next program is, we'll try with factorial. So already I have the program. I'll just copy and so I'm copying. So when you copy, just take care that that follows the pattern. So we can remove this older file, and I'll save this as factorial fact.asm. so now saved. So this is the factorial program. So here in this case, again we are going to take the value for which factorial has to be found in the from the memory. So the memory address is initialized as we have done in the previous cases. Then from the memory, the data is obtained in the R1 register. Then R2 is initialized with 0x01. So because like factorial is like, if you are saying 5, the result should be 5 into 4 into 3 into 2 into 1, but it cannot be multiplied with 0, because if you multiply anything with 0, it results in a value of 0. So we need a value which should have the minimum value, that is 1. So for that we have this R2 register that is having the minimum value as 1, so that we have initialized. Then R1, so in this case now we'll go in a fashion as such, the minimum value multiplied by the the value that you have given. Then you go for reducing the content of R1 and then multiplying it consecutively with the values. So that will happen MUL R3 R2 R1. So here R2 will have 1, and R1 will be having the input that you have given. So after you have done the multiplication, the R2 value is updated with the result, the product that we have obtained. So that goes into R2. So as far as this multiplication is concerned, you need to always use 3 registers. So you can't do with the 2 registers. Then so after the result is transferred to R2, I'll be subtracting the R1 to 1, I mean by 1, subtracting R1 by 1. So if I've given 5, so initially 5 into 1 multiplied, and the result in R3 will be 5. Then R1 content I'll be reducing it to 4. So and I'll be checking whether it has reached 0. If it has reached 0, I'll have to come out, otherwise multiplication will result in 0. So so 1 is reduced, so BNE L1. So again I am coming over here, and again I'll be multiplying the content 5 with 4 again. So 5 will be available in R2 and R1 will be having 4, so both will be multiplied, and then again the result is stored into R2. So the product has been stored into R2. Again, in the case for example, if 5 has been given, 5 minus 1 4 has happened, and now 4 minus 1 3 will happen, 3 will be multiplied with it, and it will go on, still your R1 becomes 1. So when it has gone to 0, it will come out of this loop, so it doesn't go into the multiplication process. Then I'll be adding the content of R0, that is the memory pointer, to the pointing to the next memory address, and I'll be storing the result from R3 to the memory address. So this is the explanation. So now let us see how the program works. Translate, build and rebuild, start stop debug session. Now I'll give a value 5 as I've told you the example. Now I mean the memory address has been initialized, and the data is obtained from 400005, that is obtained into R1. Then R2 is moved with 1, then multiplication happens, and your R3 will have the result 5. Then the content 5 is moved to R2 register, that is updated to R2 register. Then your R1 is subtracted by 1, so that is 4. Then it is being checked whether it has gone to 0. No, it is not gone to 0. So again it goes for multiplying this R2 and R2 and R1. So it is 14 in hexadecimal. Then again the content is updated into R2 register. Then subtraction of R1 happens, so 3. So 14 is 14 in hexadecimal is again multiplied with 3, so it is 3C. Then subtraction happens again, so 2 it becomes, then again multiplied, so it has become 78. Then again subtraction of R1 happens, so it becomes 1. So 1 multiplied with 78, again it becomes 78. So the result again now R1 is reduced to 0. So when it goes to the next memory address, next instruction, it increases the data memory address to the next memory pointer. So the 78 is stored in the result. So here you can see that the memory pointer, the program counter again goes and stays in some loop over here, and it will try to execute these things unnecessarily even after completing the program. So to avoid this, always you can have a instruction like this. You can put a L, B, L, so that after completing the set of instructions, it comes and stays in this instruction itself, so that it doesn't go to some other instructions unwantedly, undesirably. So now you can see the same okay. Now we'll have to give 5 over here. Okay, now you can see the same operation is performed. Now it doesn't go anywhere, it stays over here. 78 is the result that has been put, so it stays over here itself. So you can try this with any different numbers, maybe with 6 or 7, and you can try running it like this. So the result obtained is 13 BO. In case if you want to check, you can always use the calculator for checking 7. So you can convert that one to programmer hexadecimal. 7 into 6 into 5 into 4 into 3 into 2 into 1. So 13 BO. So we have got the correct result. So you can try with any numbers, you will get the result. This is the factorial program, factorial of n numbers. So in case the next program that we'll discuss is largest of n numbers. Again, array of numbers you can feed in, and out of which you can find which is the largest. So already I have the program. I am just creating a new file, paste it. I'll remove the older one and then save it. Largest dot asm, save. So now saved. So adding to the source group. Again, in this case also we'll have that instruction L branch L. Okay, L is again used, so we need to give some other value. So L2 will give. So 0 error, 0 warning. Fine, good. Okay, now this is the program for largest of n numbers. You can feed in the values in the sense your first as we have done in the sum of n numbers, in the memory address, starting memory address will be this one, 40000000. So wherein we'll be feeding in the on the size of the array, and consecutively whatever the values that you are feeding in which the largest of n number will be found out, and the result will be stored in the consecutive memory address. So that is the functioning of this program. So in this case again, we have initialized the R0 with 400000, and we are getting the size of the value inside the R1 register. Then we are jumping to the next memory address by this instruction, add R0, #0x04. So the first value is obtained into R2 register. When you have obtained the first value, we will have to subtract R1 by 0x01, so that the representation of one value that has been fetched is specified in the R1 register. Then when that is getting completed, I'll go for next memory address. I jump to the next memory address. So add R0, #0x04. So the second value is obtained into R3. The first value is in R2, second value is in R3. R1 will have the size of the array. R0 is having the memory address. So now R2 is having the first value, and R3 is having the second value. So we'll have this, and we'll put it in a compare statement. So compare R2 comma R3. BCS compare statement does the operation of subtracting two registers, that is R2 minus R3, but it doesn't store the result anywhere, and only the flags are getting affected after this compare statement. So BCS represents branch if carry is set. So when subtraction happens, when borrow is there, your carry flag will be reset. If borrow is not there, carry flag will be set. So actually when compare statement is getting executed, R2 minus R3 is done. When R2 value is larger than R3, then it means that borrow is not there, so your carry flag will be reset at that time. Um, if your R2 value is lesser than R3, your borrow will be set, so your carry flag will be reset, so it will be clear. So in this case, when you're checking with the BCS means branch if carry is set. If the carry flag is being set, then you'll be jumping to the next memory address. Which means that R2 is the larger memory address. So in case if the carry flag is reset, which means that it is a borrow has happened, so R2 is not the largest. So as far as this program is concerned, we'll be assuming that R2 will be having the final largest number, whatever the case may be. So when we have done the checking, in case if some other number is larger than this R2, we'll be replacing that number into R2. So that will be our algorithm. So here comparing R2, so R2 and R3 is compared. So when R2 is lesser than R3, then I'll move the content of R3 to R2. Otherwise, I'll go for next memory address for fetching the next data. So that is happening. So this will happen. So unless and until your this one is reached, your the last number is reached. So when the next value is obtained, so that is also compared again. So this happens, and your subtraction of R1 by 0x01 happens. This is the size is subtracted, then it will be checked again, whether the R1 has gone to 0. If it has gone to 0, then it will come out of the loop, otherwise it will go for fetching the value again and again. So so this does that job. Then after this operation is over, so your the result is stored inside this memory address. So I guess you can understand what is the thing that is going on. So when two values are obtained in R2 and R3, R2 and R3 is compared, and when R2 is lesser than the R3 content is stored inside R2, otherwise it jumps over here. It doesn't jump here, it jumps over here. BCS L is connected over here only, so it skips this instruction and it jumps over here, and after subtracting it goes for this L1. So this happens, and at last the result is stored inside this memory address. So we'll check how the program works. Translate, build and rebuild. So in the memory address I'll give five datas I'll give. So maybe 67 2 FF 11 1 2 3. So 312 is the largest number that we are supposed to get. So let us check. So R0 is loaded with the memory address, then the size of the array is fetched into R1 register, then 40004 it goes into, so that is the next memory address from where the first data is fetched, that is 67. Then that is compared with for before getting into comparison, it has to fetch the next data that is fetched into the R3 register. So 67 and 2 is compared, so obviously 67 is the largest. So it will jump out of this loop. So mov r2 comma r3 will not get executed. So subtracting r1 comma hash 0x01 will get executed. The bne l1, it goes into l1 again. So the next value is fetched now, that is ff is compared with 67. Obviously ff is the largest, so you'll get a I mean borrow. So it goes into mov r2 comma r3. So ff is stored into the r2 register, as you can see over here. Then branch if not equal, it decrements the r1 register by 1. So 2 it becomes, so it goes over here and it increases the memory address. So the next data is fetched, the 11. So 11 is fetched, and now 11 and ff is compared. So obviously ff is available in r2, so you'll not get a borrow, so it jumps. mov r2 comma r3 doesn't happen, it ignores that value. Then again r1 is subtracted by 1. Then bne l1, so again the memory pointer is pointed to the next one. So the last data is obtained into r3, that is 312. 312 is compared with the ff, so you'll get a borrow. So r3 will be loaded with 312. That's it. And your subtraction with r1 happens, so r1 becomes 0, so it comes out of the loop and it increments the memory address, and the r2 content, that is supposed to be the maximum value, is stored inside the address. 312 is the largest number. So this is the working of this program. In case if a smallest of n numbers you want, you can simply change this BCC to BCS to BCC. BCC means a branch if carry is clear. So if carry is clear, then it will jump. So obviously you can understand what does it mean. Carry is clear means when borrow is happening, then I'll have to jump. So always R2 will be having the smallest number. So let us check if the smallest of n numbers works. So I'll give 5, maybe 65, ff 1, maybe 12, and 1, 45. So I should get a 1 as the result. Now let us check. So the first value r1 is fetched with the size, then r2 is obtained with the first value, that is 65. Then the next value ff is being fetched. So before that is being fetched, you can see the r1 has been decremented to 4, since we have taken one value 65. Then for this ff, this subtraction will happen. So now comparison between R2 and R3. R2 is 65 and R3 is FF. Obviously you will get a borrow, so you'll jump. So moving doesn't happen because like R2 is lesser than R3, so there is no movement of content from R3 to R2. Then subtraction of R1 by 1 happens. So you can see R1 is made to 3. Then it goes and fetches the next data. So 12 is fetched. So 12 and 65 is compared. So obviously you'll not get a borrow. So it goes into MOV R2 comma R3. So 12 is stored into R2. You can see that. So it will be finding out which is the minimum number. BNEL1. So in the next memory address is pointing, and 1 is obtained, and 1 and 12 is compared. So you'll get a borrow. R2 is having 12 and R3 is having 1. You'll not get a borrow. So it gets into this move R2 comma R3, then mean again subtraction of the R1 happens. So the last value 45 we'll have to obtain, so that is obtained, and 45 and 1 is compared, so 45 and 1, so you'll get a borrow, because like R2 is 1 and R3 is 45, so obviously you'll get a borrow, so it has jumped, and 1 eventually comes as the result as a minimum number. So this is the program for smallest of n numbers. Okay, next what we are going to discuss is sorting of n numbers. So for that, again, the program has been written for ascending order, so same as like largest of n number, we can do ascending order, and we can change the ascending order sorting to descending order by changing this BCC to BCS. So as we have done earlier, we are going to save it. Sorting, sort dot asm, save, add existing file, sorry, so I'll put the sort into the source group. Now okay, getting into the program is it follows the same pattern as the largest of n numbers or smallest of n numbers. Basically it has to arrange in a fashion like the smallest should come first, and the next biggest, it should go on the consecutive pattern. So here we'll be having these same methodology as we have done in the largest or smallest of n number finding out the same thing, but in addition to that we need to rearrange the content according to the requirement. So here what we'll do is we'll have two loops. One is the outer loop and the other one is the inner loop. So inner loop will arrange the content into one direction, and after that again the same thing will be repeated the same number of times. So that is the algorithm of this program. You can see that mov r0 comma hash 0x40000 is the initialization, and I'm getting the size of the array into r1, then I'm subtracting the r1, so to specify that I'm going to take the value after that. So again here you can see that the same instruction has been repeated over here. So this is the one that I'm getting into the loop as such. You can see LDR R2 comma R0. So here the same value will be available both in R1 and R2. R1 and R2 will have the same size of the number. So R1 happens to form the outer loop, while R2 will have the inner loop. So inner loop it will get deducted each and every time the arrangement has been done after fetching the data. So R1 will keep the count of how many number of times the arrangement has been made with the whole array as such. So here now LDR R2 comma R0, so this will have the size of the array. Then again R2 is subtracted, so R1 and R2 will have the same value now. So in case if it is 5, so R1 will have now 4 and R2 will have 4. So add R0 comma hash 0x04. So now I'm getting into the elements, fetching the elements. So LDR R3 comma R0 within brackets R0 fetches the first data. Then add R0 comma hash 0x04. LDR R4 comma within brackets R0 fetches the second data. So compare R3 and R4. So this is ascending order sorting. So in case if R3 is smaller than R4, we are going to leave it free. We are not going to exchange do anything. So R3 and R4, when it is been checked, if R3 is lesser than R4, obviously you will get a carry, you'll get a borrow. So when you get a borrow, your carry flag will be reset. So when so that's the reason BCCL has been specified. BCC means branch if carry is clear. If carry is clear, I am jumping to the SUBS R2 comma hash 0x01 and BNE L1. So in case if R3 is larger than R4, then what I'll do is I'll be swapping the content of in the memory itself. So str R3 comma R0. So R3 value goes into R0. R0 is having the presently this memory address, right? So whatever I have fetched into R4, that memory address is available in R0. Towards it I am moving the R3 content, then I am subtracting R0 by 4 so that it goes to the the memory address of the content that has been fetched into R3. So towards which I am moving the content of R4. So swapping has been done in this way. Then after swapping has been done, I'll have to return to the same memory address whichever it was pointing it before. So for that reason I am putting add r0 comma hash 0x04. Then after that subs r2 comma hash 0x01. So I am subtracting the r2 content and I am checking whether it has gone to 0. R2 is having the size of the array, R2 and R1 is having the size of the array. So when this has got completed, then I'll be fetching the next data into next data will be obtained, that is like whatever the thing that is available in R0 will be having the data that is confined with the next memory address. So that is obtained into R3, and one more memory address is incremented. So from that the data is obtained into R4. So R3 and R4 is compared, and again it follows, it goes on till your R2 goes to 0. When R2 goes to 0, then you go for subtracting the R1 with 1, and then here also we can directly put BNEL2. So you can do this instruction also, CMP R1 comma hash 0x00. So to show that this also can be done, I have written like this. But SUBS when you are making, so BNE is sufficient, CMP it's not required at all. So BNE L2, so it goes to the L2 and it initializes the memory address from the beginning again, and it does the same procedure of swapping or checking two elements. So let us now check with the program. So now here I'll give 5 values. To 8 and maybe 9 I'll give. So now 5 is the size of the array. 1 2 3 4 5 elements I've given. So now let us check. So first R0 is loaded with the memory address and the size is obtained in R1. Then I'm jumping to, sorry, this is available in largest of n numbers itself. So sorting, we haven't done this translate, build and rebuild. This is one again an important instruction. In case if you think that you have done the translate, build and rebuild, and if you haven't really done, this will happen. So when you get into start stop debug session, instead of running this program, it will run the old program that has been already you have done this translate, build and rebuild. So obviously be careful while you are doing this operation. So start stop debug session. Now I'll give the values again. 5. So here I'll give 7 and 1. and maybe 4, 2, 2, and here I'll give maybe 3. Okay, now let us check. So first data is obtained, that is the size of the array is obtained in R1 register, so subtracting it, it becomes 4. Then again reinitialize the R0 with 400000. Again 5 is fetched into R2 register, then R2 is subtracted by 1, then add R0 with 4, so it goes into the next memory address, that is this one. Then R3 is fetched with that content 7, and then add R0 again, so now 1 will be fetched. So R3 is 7, R1 is 4, so 7 and 4 is compared, so you will not get a borrow, so it goes into swapping now. So you can see now R3 content is 7, so your memory pointer R0 is pointing 40008. So then now after this instruction, R3 content 7 will move into this 40008. So the over here the swapping first part is happening now. So 7 is loaded, then subtract R0 by 4, so this will become 400004. So now R4 content, that is 1, is moved into 400004. Okay, now 1 is moved, so swapping has been done successfully. After this the memory pointer has to be brought back to its original memory, so for that reason add R0 comma hash 0x04 is done, so it becomes 400008. Then again subs R2 comma 1, because like the second time, I mean I have obtained the data, 2 data has been obtained. So once it has been decremented in the beginning, now again it is decremented and it has been checked now whether it has gone to 0 or not. So it has not gone to 0, so I am coming to the next. So over here now 7 and 4 will be fetched and it will be compared. So now R3 is fetched with 7 and R4 is fetched with 4. So now again 7 and 4 is compared, so you will not get a borrow. So again swapping should happen. So you can see that 7 has gone to this memory address while 4 will come over here. So 4 has been swapped, 4 and 7 has been swapped. Then subs R2 comma 0x01, so it becomes 2 and checks, and it has not gone to 0, so again it repeats the procedure again. So now 7 and 2 will be compared, because like your memory address is 40000C, so that 400C is associated with this particular memory. So now 7 and 2 will be compared. 7 and 2 is fetched and 7 and 2 is compared. So here also you will not get a borrow, so swapping will happen. So 7 goes over here and 2 will come over here. So after that subtract R2 and again it goes to do the comparison between 7 and 3. Okay, now 7 is there in R3 and R4 is having 3 again, and both are compared, 7 and 3. You will not get a borrow, so it gets into swapping again. So 7 and 3 is changed, and after that your R2 becomes 0, so it comes out of the loop and it subtracts R1 with 1 now. So you can see R1 has become 3. So R1 has become 3. So now the inner loop arrangement has got completed once the checking and arrangement has completed. But you can see that 1 4 2 3 7 it has been arranged. So it is supposed to be arranged as 1 2 3 4 7. So to obtain it, that's the reason we are having this outer loop. So now it is getting into the outer loop, and it decrements the R1 and it compares and it goes for reinitializing the memory address to the starting memory address again. So you can see over here it is changed, and then it fetches the content again as 5, R2 as 5, but R1 remains 3 only. So R2, so this part is repeated again, the inner loop part is repeated again. So now again the same procedure of 1 and 4 is now compared. 1 and 4 is obtained in R3 and R4, and that is now compared. So so you'll get a borrow. 1 and 4, when it is compared, you'll get a borrow, so it will jump. So it is jumping now, and R2 is decremented by 1, so R2 becomes 3. Then it jumps to LDR R3 comma R0, that is like it goes to the next memory address. So in R3 will have 4 now, and R4 will have 2 now. So yeah, R3 is 4 and R4 is 2. So 4 and 2 will be compared, so you will not get a borrow, so swapping will happen. So you can see yeah, here you can see 4 and 2 will come over here. Okay, you can see that 2 has come. Then again subtraction happens, subtraction of R2 happens, that is the size happens, and it checks whether it has gone to 0, and still since it has not gone to 0, again it goes to goes for the next value. So again now 4 and 3 is compared, because 4 is being fetched and 4 and 3 is compared. Obviously when 4 and 3 is compared, you will not get a borrow, again swapping will happen. Okay, now 4 and 7 has to be compared. So since your R0 is available in 400010, that is pointing towards this memory. After the swapping, whatever the value is available, that only will be fetched. So 4 is fetched into R3, and R4 will have 7. 4 and 7 is compared, you will get a borrow. So you jump out of this loop and you subtract R2. R2 now again it has gone to 0, so again it comes out of the loop and it goes for subtracting the R1 content by once. Then again, now by this stage already the sorting has happened. So but your outer loop will try to check it. Mean if it is 5 number of times it will try to check the content. So this will happen. Now R1 also has gone to 0. That's it. That's the end of the program. So 1 2 3 4 and 7 is the value. So in case if you want to change it to descending order program, that also you can do, as we have done earlier. The best practice is writing this one, L3 branch L3. So as I've already told you, we can change the ascending order program to descending order by putting simply this, changing this BCC to BCS. So now let us check. Okay, same 5 numbers will give, and in this we'll give say 8, 9, 1, 2, to FF. So let these numbers, will try to sort it in descending order. So as earlier, 4000 is obtained and the size is obtained, then same size is obtained in R2 register also, then the memory pointer is incremented. So second value 8 is fetched into R3 and 9 is, 9 is fetched. To fetch that, this incrementing this memory pointer is happening, so 9 will be fetched. So 8 and 9 is compared, so you will get a borrow. So if a borrow is there, so your carry flag will be reset. So obviously BCS means branch of carry is set, then only it will branch. If borrow is happening, branch carry is clear, so it goes into this particular instruction. So that is swapping. 8 and 9 has to swap, so that has happened. Now you can see 8 and 9 is swapped. Then again subtract R2 by 1, then it goes to fetching the next value. So 8 and 1 will be compared now. So now 8 and 1 is compared. So when 8 and 1 is compared, you will not get a borrow, because 8 is larger than 1, so you will not get a borrow. So obviously when your carry flag will be set, so it will jump out of the loop, so no swapping is required. So R2 is decremented by 1, and again it is checked with whether a 0 flag is set, then it comes to fetch the consecutive value. So now 1 and 2 is compared. R3 is 1 and R4 is 2. So in this case again the swapping has to happen. You can see this will change to 2 and this will change to 1. Okay, now you can see 2 and 1 has changed. Then consecutively the next 1 and FF will be compared. So obviously that has to be swapped, so that has happened now. That's it. So with that your R2 has gone to 0. So again it will restart the rearrangement by swap, rearrangement of sorting from the beginning again. So for that it will decrement R1 by 1 and it goes to the beginning again and reinitializing the memory address. So reinitializing happened, and then R2 is loaded with 5 again, and 5 is that is decremented by 1. Then the first value 9 is loaded, so 9 and 8 will be compared. 9 and 8 is compared. So so you will not get a borrow, so in that case it will jump, so no swapping occurs. So now 8 and 2 is compared, again no borrow, so it will jump. This is the swapping part where it, you can see that it does not got executed, so it jumps to the subtraction instruction. Then again 2 and FF is compared, 2 and FF, so swapping has to happen, so it gets into the swapping part. So 2 and FF is exchanged. You can see 2 and FF is exchanged. Then subtract R2, then BNEL1, then again 2 and 1 is compared. As it is a descending program, yeah, 2 and 1, so you'll not get a borrow, so it jumps. So again it goes to the beginning, reinitializing the memory address, then fetching the size, then going to the values 9 and 8 will be compared now. So 9 and 8 again you don't have to swap, but then the next thing is 8 and FF, so it will be compared. So in this case you'll get a borrow, so swapping will happen now. You can see FF and 8 is swapped. Then SUBS R2 BNEL1. Then now R3 does have 8 and 8 and 2 is compared, so you'll not get a borrow, so it jumps, and then 2 and 1 it will be compared, so you'll not get a borrow, again it will jump. So that is the end of the third iteration. So now again your R0 is reinitialized, then R2 is so you can see till this end the full swapping sorting hasn't occurred, because like the first value is 9, but first value is supposed to be FF, then 9, 8, 2 and 1 is the result. So you can see at the last iteration only this FF and 9 is swapping, but when we are taking the previous program, that is ascending, within 2 iteration itself it has got sorted. So this is this I have made it to show you that in some cases the full completion of sorting will happen at the last iteration only. So here now you can see it starts from the beginning again. So your R3 is 9 and R4 is EFF, so 9 and FF is compared, so you'll get a borrow, so your swapping happens. Yeah, FF and 9, so almost in this iteration now the sorting has got completed. So now 9 and 8 will be compared, so swapping doesn't occur. Then 8 and 2 is compared, swapping doesn't occur. Then 2 and 1 is compared, swapping doesn't occur. Then you are subtracting R1 by 0, so that's it. That's the end of the program. Now the value that whatever we have given is sorted in descending order. This is the explanation for the sorting program. Thank you.